So this video is going to be on concavity, and we can tell the concavity of a function by looking at its second derivative. So if f double prime is greater than 0 on the closed interval from a to b, then f of x is concave up on the open interval from a to b. If f double prime is less than 0 on the closed interval from a to b, then f of x is concave down on the open interval from a to b. So visually, we'll just look here. So the image on the left side is concave up, image on the right side is concave down. So over here, f double prime is greater than 0, and then on this side, f double prime is less than 0. That means any point, if we evaluate the second derivative at any point, on this side, on the left side of this curve in this picture, that means the output is going to be positive. Okay, so even though the slope is decreasing on this side, because it's concave up, the rate of change is increasing. Therefore, the second derivative is going to be positive. And then the same can be said about the concave down on the right side. If you were to evaluate the second derivative for any of these points, they will be less than 0. We're also going to talk about inflection points. So on the left side, we have concave down and then concave up. In order for the concavity to switch, there has to be a point of inflection. So here, it's going to be at x equals 2. In the previous image, it is at x equals 0. So for this one, f double prime is greater than 0 when x is greater than 2, because it's concave up. And then f double prime is less than 0 when x is less than 2, because it is concave down. And then at f double prime of 2, that will be equal to 0, because that is a point of inflection. And that's where the second derivative will be changing signs. So it goes from negative to positive. Therefore, there's a point of inflection. All right, so number 14. Part A says sketch a sign pattern of f of x. Now for us to do that, we need to write this in factored form. So we have f double prime of x is equal to 7 minus x times 7 plus x. Okay, so now from here we can go ahead and draw a sign pattern. To make this easier to see, we can factor out the negative sign from the first binomial. So that'll end up being x minus 7. And then we can rewrite this as x plus 7 to truly see the x-intercepts here. So we have negative 7 and positive 7. Now we have that negative coefficient, which means the interval to the right will be negative. They both have a multiplicity of 1, so we will have a sign change. That is part A. Part B says identify the domain in which f of x is concave up. So because this is a sign pattern of the second derivative, where it's negative, f of x will be concave down, and where it's positive, f of x will be concave up. So f is concave up on negative 7 to 7 because f double prime is greater than 0 on that interval. Part C is asking determine the x values in which f of x has inflection points. So this is going to be where f double prime is either undefined or changes signs, okay? So for this one, f has inflection points at x equals plus or minus 7 because f double prime changes signs. All right, number 15, we have f double prime is equal to negative x cubed plus 3x plus 2. And we need to get this in factored form. So we have a hint. X equals negative 1 is a 0, so you can use synthetic division to go ahead and begin the factoring. Don't forget your 0 placeholder for x squared. And then for synthetic division, we multiply, add. So we'll pull down the negative 1. Negative 1 times negative 1, we get positive 1. 0 plus 1 is 1. Negative 1 times 1 will be negative 1. 3 minus 1 is 2. and then we have negative 1 times 2. We have negative 2. 2 minus 2 is going to be 0. And then this remainder of 0 just proves that that is, in fact, a factor. All right, so if negative 1 is a solution, that means we have x plus 1 as a factor, and then we have negative x squared plus x plus 2. To factor this more, we need to factor out that negative sign. So we have x plus 1 becomes x squared minus x minus 2. We need two numbers that multiply to negative 2 but add up to negative 1. So we'll have x plus 1. I believe we can use negative 2 and positive 1. Okay, so now we have two factors that match, so we can combine them. So we have x plus 1 squared, x minus 2. That's important because that's going to change what our sign pattern is doing. So we have two values on our sign pattern, negative 1 and positive 2. All right, we have that negative leading coefficient again, so that means the right interval will be negative. The x minus 2 factor has a multiplicity of 1, so it's going to change the positive. The x plus 1 has a multiplicity of 2, so it's going to bounce, so it's going to stay positive. Okay. Part B, we want to identify where f is concave up. So f is concave up on negative infinity to negative 1 union negative 1 to 2 because f double prime is greater than 0 over these intervals. Now in second period, maybe second and fifth, we talked about, can we just say negative infinity to 2? Well, if you plug in, if we do f double prime of negative 1, what do we end up with? We have negative times 0 squared times negative 1 minus 2, all right? Which means this is going to be equal to 0. Now, for f to be concave up, the second derivative has to be strictly greater than 0. Therefore, we cannot include negative 1 within this interval because 0 is not greater than 0. Okay, so we have to use two separate intervals for this. Part C is asking about inflection points. So f has an inflection point at x equals 2 because f double prime changes signs at x equals 2. All right, hope this was helpful.